just these 4 here, but these are some of the most popular that you're going to be seeing used in data analytics. So now it's your turn to give it a try and test out these tuples. A lot of these concepts are going to be very similar to what you've already learned previously with lists, dictionaries, and also sets. With that, see you in the next one. Quick check-in before we dive into this section on operators. We're about halfway through with covering the basics of just Python itself, core Python. Once we get through these core basics, then we're going to be able to move into things like pandas and matplotlib, which are going to allow us to actually dive into that data set and actually explore it that I've been teasing this entire time. So I bring that up to let you know there's a light at the end of the tunnel. We're almost halfway through of the core functionality of Python. You should be really proud of the work that you've put into so far in learning this. I promise you it's not going to go to waste. For this section, we'll be covering 4 different operators. And we're going to be starting with logical operators first, which are denoted by key terms like and, or, and not. So what's the purpose of the operators? Well, they can be applied in multiple different ways. So in our data set, we have columns on whether a job is classified on work from home, whether it has a mention of a degree, and whether it has health insurance or not. And this is classified as either true or false for meeting a condition. So let's dive into putting these operators to work. But if we're going to start by defining a variable of job work from home and set it the value of true. We'll also create a variable for job health insurance and set it also to true. So let's say we want a job that is work from home and also requires health insurance. How could we actually check this? Well, we can use that and operator. And I do job work from home and job health insurance. And what we're doing in this case is comparing whether both values are true, and if they are, return true. Now, I'm looking for a job that is requiring both of these situations to be true. So if I said maybe health insurance, maybe it's false. Running this now, it's going to be providing false. Anytime either one of these are not true, it's going to be false. And we're not limited to just comparing 2 values. We can compare any number of values. We'll add an additional variable of job no degree mentioned, so whether a degree is required or not for the job itself. We'll set this to true. And then from there, I'll just add it on with an and statement, adding in that job no degree mention. Okay, running this still, we're going to be checking to whether all of these conditions are true. We're using an and statement for each. So as you'd expect, we're going to get false. Unless we have every single one of these is true, we're not going to get a true statement back. In this case, we will. Now let's move on to that or operator for the time being. We're going to get rid of this job no degree mention. Let's say we only want to meet one condition or the other. We want to either work from home or we want health insurance. Doesn't matter which one it is, but we just at least want to have one of these to be true. In that case, we can use an or statement. And if either of these are true, as we're going to see, it's going to get true. However, if we change one of these to just false, we're going to get true still because we meet one of these conditions. Only in the situation where both of these are actually false are we going to get a false return. Adding back in that job no degree mention and then removing this here right here. This one's put as true. We can do once again like and multiple conditions. The last keyword to cover in this is not. And not just goes through and changes which way where the true or false statement is going. So in this case, I'm putting not true. It's going to return false. So in the case of here, if I want to do job work from home, job health insurance, and then for some reason I said, oh, I care about the opposite of whether a degree is mentioned, I put a not statement in here. Now I'm going to change that to false. These logical operators are going to be used in a lot of different functions and a lot of different operations. Specifically, we've covered already conditional statements. And so using like the if keyword, I can put our different values in here that we're evaluating for the if statement, put a colon. And then for there, I print meets conditions. So running this, do we meet the conditions of this? Running shift enter. No, we don't meet the conditions of it. The next one to cover are membership operators. They're checking whether an object is inside of another object. So jumping into an example of this, I could check whether something like data is inside of the term data nerd. Running this, I would expect it to return true because it's inside of there. Now this is case sensitive. So if I was looking for a lowercase data inside of here and running this, it would return false. I do see it time to time used with strings, but I see it more specifically used with things like lists. And think of that, I think of our job skills list. So here I have this one defined with only 3 skills, but imagine we have a list with hundreds of skills in it and we need to check it for, does it contain a value? Well, I can say what I want to check for. So in this case, Python in job skills, and then check it. Conversely, if I want to verify a skill is not in a list, I would just use that keyword of not. And in this case, it returns false. This is the one thing I love about Python. It's so readable. You can just read it right here. Python not in job skills. Moving on to identity operators. These are used to basically identify whether something is correlated to another item. Now this commonly gets confused with the comparison operator. Say in the case of here, I wanted to compare the values of salary for Kelly to the salary of me. In this case, we can look at it and see, hey, they're both equal. Running this Shift Enter, we get true. Those new to Python may confuse this with the is operator. Salary Kelly is Luke. So running this, we're actually going to get false because these values are not equal. So why is this? Well, the technical reason is the is operator is, it sounds like improper English, the is operator is verifying if these two variables are using the same memory location for the value that they're holding. So if you remember, I used that ID function before to return the identification number or the memory location of a certain variable. So I can do here, salary Kelly, running the Shift Enter, and then I'll also do that of salary Luke, running Shift Enter as well. We can see that these values are not equal. I can even actually, this is actually a pretty good use case of doing this. I can take this and I can set this equal to it. Are these values equal? In this case, no, they're false. So when would using this identity operator in data analytics be relevant? Well, to be honest, not really going to be relevant, but I want to make sure you actually understand it because it does show up from time to time. A potential case of this is, say we had a list of core skills of Python or SQL, and then we said, hey, these are Luke's skills. They're equal to core skills. And then running this Shift Enter, we set them equal to each other. In this case, we can use that is operator in order to verify if it is in fact the same item. And it turns out it is the same item. They're both I have the same ID, so therefore it's true. The last operators we're going to be going over are bitwise operators. And when I say go over, we're really just going to briefly review it so you're aware of them. These operators are used in conjunction with understanding the binary value. So if I did this bin function to look at the binary value of something like 42, running Shift Enter, I can see that that's basically what the computer is reading 42 as. These operators are working to compare that first bit of these binary values and then returning certain values depending on it. We're not going to go into it much. Mainly, I want you to be aware of it because this and symbol, this or symbol, and then this also not symbol is actually going to get reused again. Basically, it's going to get overridden whenever we get into pandas. So I want you to be aware of it, that these symbols are available. So although we covered 4 different operators in here, and now we've covered a total of 7, for this section right here, I want you mainly just focusing on those logical operators and also membership operators. Those are the most important ones that there are when it comes to actually analyzing data. All right, so you have some practice problems around those. And with that, I'll see you in the next one. Don't repeat yourself or dry is a core principle in programming. And loops are one of the ways we can go about in ensuring we're not repeating ourselves. It not only looks bad, but it's very inefficient to have repetitive lines of code one after the other. And for loops and while loops, of what we're going to go over in this video, help solve that. So let's jump into a quick example of how powerful these type of loops are. Don't worry if you're not following along, we're going to go dive into it deeper further. The main purpose of this, I want you to just understand the power of this. So I have this list that I've already defined and imported from the data set on Data Science job posting, and it's a list of all the job titles from the job postings in the data set we're going to be working with. You can see things like here, we have data engineer, senior data engineer. Do we have any data analysts? What's going on here? Okay, data analyst, financial and regulatory reporting. So a lot of different jobs in here. If I actually want to see the length of this list of how many jobs we're going to be going through, Scrolling. Oh my goodness, what's going on here? So if I actually wanted to see the length of these jobs going on here, I can see that there are 787,000 different jobs in here. Now you could think if I needed to go through this list and maybe identify, like I was trying to do, how many data analyst jobs are inside of there, this would be very cumbersome to do one by one. But this is where for loops and while loops can help us. So let's say I want to get a collection of all the different data analyst jobs within this list, and I want to put it into its own list. I'd first start of defining an empty list of analyst list. And then from there, I can use a for loop to iterate through the job list that we have. Don't worry, we're going to go over syntax in a little bit, but you could pretty much read this, right? For job in job list. I want to evaluate if it contains data analyst. If data analyst is in that job itself that we're going to be iterating through. So that each one of those items in the list can be iterating through, checking to make sure that data analyst is in it. If it's so, we want to do something. What do we want to do? We want to add it to that analyst list. So we'll do analyst list dot append, and we'll append that job. So running this, pressing Shift Enter, we go through it. You can see it was done in, well, less than a second. We went through 700,000 jobs. Anyway, let's actually look at that analyst list. Printing it out, pressing Shift Enter, we can see all these things inside of here have data analyst within the job title. And if we wanted to see the length of it, I could just see length of analyst list to see how many out of that 787,000 are there. So 163,000 out of that are data analyst jobs. So you can imagine what we can be able to do with these for loops. Let's actually dive into it further. Break this down to using a simple example. We have this list called numbers. So we're going to start this for loop with the keyword for. From there, we're going to define a new variable for each of those, in this case, numbers we're going to cycle through. So we're going to write number. This is a new variable only going to be used within this for statement. And from there, we're going to use the keyword in. For number in numbers. And numbers is your iterable that we're going to be iterating through. We'll jump into more about iterables and iterators here in a second after we get through this. So for number in numbers, we want to do something. We're going to do something simple right now. We're just going to print the number. Pressing Shift Enter to actually see. It goes through number by number and prints it out right below. So getting back to this iterable of here we have numbers and it's a list. What data types are iterable? Well, everything we previously covered on dictionaries, lists, sets, and tuples, conveniently what we covered before this, is iterable. So you can use it in this case. Additionally, you can do other data types as well are iterable, such as a string. Let's say we had a variable called characters and we set it to the value of Python. Similar to before, I can define a for loop saying for character in characters, print character. Running Shift Enter, we're going to get printed out Python. This variable right here can be anything that you define it. I mean, that can make it as simple as an underscore and then also put this underscore right here. Running Shift Enter, it's going to give me the same results. So let's move into a real world example with using for loops. Let's say I have a dictionary of job applicants for a jobs, and I'm looking to hire somebody with more than 5 years of experience. So this only has 4 values in it right now, but really, I mean, I'm sure any type of job application process is going to have way more than this. Fun little fact with this, you can generate any type of data that I'm using for this course even more quickly by using something like ChatGPT. Let me show you. So inside your favorite chatbot, prompt it something like this. Generate a Python dictionary titled years experience with name as the key and years as the value. Use random values for each. Make it 20 items long. And once it generates the code, in this case, it wants you to run the code to actually generate this dictionary. I was hoping to give it to you, but nonetheless, we can still do it. I can just paste the code right in, pressing play, seeing we have years experience, and this has even more values than we had before. We're not going to use this one, but this is just something to be aware of. We're going to use the same years experience that I just generated with only 4 values. So I like to start simple whenever building something like this. I'm just going to start by saying for, and I'm going to give it a variable of person in years experience. And then we end that with a colon, remember? Pressing enter, making sure that it's indented in. I just want to print out person. Now remember, when we're iterating through each one of these items in this dictionary, what's it going to print? It's going to print the key and the value. Is it going to print both? Well, let's find out. So how do we get the values out? Well, we're going to use my favorite function for this, help, and go into dict to investigate how we could potentially get this out. Inside of this help class on the class dict, we can see they have this method right here called values. It's ran on the dictionary D, and then an object providing a view on D's values. So we can use this for the values. So for this, I'm going to add in the method 2 years experience of dot values. And I know I'm getting the values now out of this. So instead of doing person, I'm actually going to title it what it is. It is value. And then I'll put it inside of here because we're no longer using person. Running this again, shift enter, we get the values out of it. Okay, so we learned how to get the keys and we learned how to get the values. How do we get both? Well, the next method you need to be aware of is items. And dictionary.items provides a set like object providing a view on D's items or dictionary items. So in this case, this set is going to be basically key followed by a comma and then value to have that set of the key and value. So I'm going to go up here and modify this further, and I'm going to change this method now to items, and I'll change that first variable to key, comma, value. So it's going to say for key value, which is the tuple-like object, in years experience items, I want to print key value. Shift enter. We got Luke 3 all the way through. You get the point. Now remember the point of this. We're trying to find an applicant that has greater than 5 years of experience. So let's modify this further. We're going to be using an if statement to basically now check if a value is greater than 5. If so, what do we want to do with this? Well, we want to alert to whoever's using this that this key has, and then from there, has whatever number of years experience. So running this, pressing shift enter, we can see that Kelly has 6 years experience. There's no more in here, so only Kelly's going to appear right now. So wrap this up on for loops. We have to use some sort of iterable to iterate through to check all the different values. If you remember from that last video, we went over that range function. I just want to cover this real quick because you may see this. And we converted this from here into a tuple to actually see the different values inside of it. So range is commonly used within for loops to actually iterate over a certain number of things. Like say I need to do something 100 times. So I could say for blank in range of 100, I want to print that blank out. So shift enter, and I have a syntax error. Can't forget the colon, and it prints out all the different items. So you'll commonly see this type of syntax, specifically this range function being used. And so I just wanted to make you aware of it. Next up is while loops, and while loops are checking for a condition similar to what if statements do in checking conditions on whether it's true or false. And while it's maintaining true, the condition underneath it's going to continue to execute. So it follows the syntax of while and then the condition. In this case, I'm going to just throw in true and then a colon, and then underneath it, what we want to do. Well, in this case, we want to maybe just print data nerd. Okay. I don't recommend running this on your computer, but I'm going to go ahead and run it. And it's going to continue to run and run and run because it's always meeting this while condition. I'm going to go ahead and press stop right here. Hopefully it stops. Okay, good. It stopped. Now, if I change this to while false, it's never going to meet this condition underneath here. So running shift enter and scrolling to it, we can see that we have while false, print data nerd. Nothing's printed out underneath it because it never meets the condition to do that. Now I'm going to give a caveat with this. While loops are very much less common than for loops. For loops are so powerful with what you can already do. I really don't find too much of a need for while loop. But while loops, for those that have maybe coded in something like VBA or R, may be familiar with something like this, where you have something like a count, and we'll start this count at 1. And while the count is less than 5, we want to, didn't get done printing that out. We want to print the count. And for each one of these occurrences that we're going through, we're going to add 1 to each one of those occurrences. So now running this, what happens here is it prints 1, 2, 3, 4. Once it gets to 5, it doesn't meet that condition, doesn't print it out. You're probably like, Luke, why do I have to learn about this? Well, there are some conditions that you may meet that you need to do this. So going back to that years experience dictionary that we have, imagine this thing is super long and we need to go through it, but we only care about returning the first instance of meeting condition. And then from there, we can just terminate it. We don't need to move on. We want to just find one occurrence of it. So in this case, we want to find an applicant that has more than 5 years of experience, but we just want to return the first applicant. So I'll add in Mary with 7 years of experience. So we're going to start with a while loop to check if the value inside these dictionaries, so we're just going to call it years, is less than 5. We want it to stop whenever it gets greater than 5, so we don't want to continue on. So already I see that this years is has a yellow squiggly line underneath it. So I need to just go ahead and define it right now. I'm going to define it, set an initial value of 0. Okay, now I want to iterate through all of these years experience. If you remember, dictionaries are unordered. And so we can't use something like an index to iterate through it. But we can actually convert this dictionary into a list, and then it has an index for each of these key value pairs in order to iterate through. So let me show you what I mean by this. I'm going to actually, I know I haven't finished this while statement right here. I'll say this is the years list. In here, we're going to define that we want to create a list out of years experience. Let's actually see what this looks like first. I'm going to comment out this line right here, pressing Shift Enter to see what years list actually looks like. We can see it only has the values in it. So we remember we need to put in that items method in there to actually convert that into key value pairs. Then running this, it's a list of set items through here. And if I wanted to access one of the items in there, remember we can use that square brackets and then define like, hey, I want to see the last item in this list. Press Shift Enter. I put the 3 in there and I'll get Alex. I don't know why I said last, not the last item. Anyway, getting rid of this, let's actually get back into programming that while loop. So while years are less than 5, remember we started out with it being set to 0. We converted our years into a list. We want to get the key and value from this years list. And remember, we have to define it an index. Now, once again, when I get done this index is not defined yet. We also want to define this as 0. Just for troubleshooting's sake, I'm going to go ahead and print out each one of those key value pairs. Now, the other thing to do is, right, we have that index. We want to be iterating through each item in that list. So we need to add to it like we did before with the count by using that plus and a sign and do it by increments of 1. So let's go ahead and do this, run this now. All right, so silly me, I said while years less than 5. Right, we don't have a value in here for years. Technically, this value we need to actually use right here. It should be the years itself. And we'll change this also to years. So let's actually run this again. Okay, so in this scenario, we printed out Luke and then Kelly. And then as you can see, it goes through each one of these. It prints through each one of these. So now we're getting closer to what we want. I don't necessarily care about printing out this Luke at 3 years. Remember, we just want to see Kelly, and that's it. So now we're going to include an if statement here. So if years are greater than or equal to 5, we want it in that case to print out. So run this again. We can see now we're only getting Kelly. And then we'll just add a little amplification here of key has so many years of experience. Running this, we now see Kelly has 6 years of experience. So as you can tell from that for loop was a lot less involved than that while loop. And luckily for you, you're probably going to experience more for loops than you do while loops in data analytics when using Python. So that's one thing good to know about this. All right, so now it's your turn to give it a try, testing out those practice problems for different for and while loops while building on, as you've seen here, all those different things we've learned previously on lists, sets, tuples, and dictionaries in order to combine this knowledge. We're really building up, and you're going to be surprised at the end of this course how much you actually do know. All right, with that, I'll see you in the next one. As we move forward in this video, we're going to start combining a lot of the things we're learning. Specifically here, we have list comprehension, which combines basically lists and also loops. So what is this list comprehension? Well, we're going to show it real quick with code. We're going to break it down even further as we go throughout this, but I just want to show an example real quick. In this, the list comprehension or the what's going on is inside of the brackets here, which is a list. And what we're doing is we're generating numbers from 0 to 100. And if I go ahead and print out this variable underneath it, pressing Shift Enter, we can see that it has a list of values from there to 100 or 99. So let's actually think through what we'd have to do if we didn't know about this list comprehension and we just needed to generate it with the knowledge that we had already. The first thing we'd have to do is define a blank list. Anytime you want to define anything blank, a dictionary or whatever, or even list in this case, you just put the brackets and you don't put anything in there. Then from there, we'd need to iterate through a loop and put it into this blank list. So I would use for number in, we'll say range 100 because we want to do the same thing. We want to add that number to the numbers list. So we'd use numbers.append and inside of here, put number. Underneath this, I want to print out now what we did here and print out that numbers list. We've done the exact same thing that we did before from 0 to 99. And so look at this. This is a lot more succinct whenever we did this previously in only one line of code compared to this right here, where it took multiple lines of code and multiple basically unnecessary steps that we can make and compress, if you will, in making a list. So let's go over the syntax of this. So walking through this step by step, we're going to start by defining the list comprehension we're actually doing by doing these square brackets. And the first argument in here is the variable that we want to put into this list. So in this case, we're going to just define it. We're defining it right now, X. We haven't defined it yet, but we are going to. After this variable, now we need to use a for loop, if you will, to now iterate through what we want to. So in our case, we wanted to generate the numbers from 0 to 99. So we'd use for X in range 100. So with this syntax, we're basically going through and iterating through this iterator of range 100. Each item that it gets, it's adding to the front to this X right here, and that's getting added to the list. So running this and actually printing it out below, I'm going to say numbers, Shift Enter. Okay, so everything's printed there. Now let's modify this to actually show what's going on here further. Let's say I wanted to do an operation to each one of those numbers as we're iterating through 100. In this case, let's say I wanted to multiply them times 2. So every time that I'm cycling through each one of these numbers, it's multiplying the value times 2, adding it to the list, and then we have our final list. And here we see we have this new list where basically everything is going by 2s until we get to around 200 or 198. And then we're not limited to just doing math operations. I can even do things like maybe I want to convert X to a float. And doing this here, now I have all these different items converted to a float. Moving on to the iterator itself of that range 100, we're not limited to just using range 100. We can use any item that is iterable. And we talked about list sets, tuples, dictionaries, and things like this range function are iterable, and even things like strings. So if I modify this, changing and removing that float, I can put inside of here if I want a string to iterate through. In this case, I'm going to put in Python running. I know it's called numbers, but we're not going to change that. Running through that, we have the final values of Python inside of a list. And although this section is called list comprehension, we're not necessarily limited to just doing list comprehension. We can do set, tuple, and dictionary. All you have to do is actually change what's going on with the brackets themselves. So instead of using square brackets, I'll use curly brackets in this case, running Shift Enter. We get, well, you can't read that anymore because now we're using a set, but it has the letters of Python in there. You're probably like, Luke, what's the purpose of this list comprehension? What are the real world example? Well, if you recall back to the last video where we actually went through and analyzed that job list of almost 700,000 different jobs for whether they contain data analyst and then put that back into a list, we can basically do the same thing with list comprehension. I know we have this added if statement in it. We'll get to that in a second, but we can do this with list comprehension. So I'm going to start out by defining that list of analyst list. And then from there, starting it by opening the brackets. And we're going to define a variable. We're going to be iterating through that job list. So I'm going to name the variable job. And so we're going to cycle through that by saying for job in job list. All right. So we're going to stop right there and just print out where we're at. I'm going to print out analyst list, and it has a whole bunch of values. I'm actually curious to see what is the length of this list itself to make sure that we have all the values there still. Okay. So we still have around 787,000 things in there, which if we actually look at the length of job list, running Shift Enter, we can see that they do match. And I actually modified this further to make it more readable. And now we can compare original list is this, new list is that many jobs. Anyway, let's continue on with our list comprehension. So we've already defined that we can do the for here. Now let's incorporate this if statement in there. And as you're probably guessing, you can just put this right after the for loop. So in this case, if, and then from there, I'm going to define a condition. For now, we're just going to put true in there to show it. I'm going to run it. So we're going to iterate through each item in the list. From there, it's going to check if it's true, if we meet this condition for that item. And if it is true, it's going to put it in. So whenever I run this next one, okay, I still have the same amount of jobs in there. Now, if I change this to false, nothing should get put into there. So I'm going to run it, run this one. There's now 0 jobs in it. So we're going to change that if condition to be what we were trying to use before of data analyst in job. And now running this one and then this other one, we can see, like as before, original list has around 700,000, new list has around 163,000. And when I go to actually print out this list to inspect it, we can see all these different jobs have data analyst in the title. So this is a pretty awesome feature that we were able to condense down. Here we had 4 lines of code, I'm not counting this space right here, to 1 single line of code. And I also feel it's a heck of a lot more readable to actually go through and understand what we're actually doing here in generating this new list. All right, enough of me yapping. Now it's time for you to actually dive in and test out these different list comprehension methods by some practice problems that we got for this. With that, I'll see you in the next one. So we've been going pretty hard at learning all these different fundamentals about Python, and I want to go through an exercise combining all of these different things that we've learned so far in order to showcase an example in a real world scenario. We'd want to actually use these type of skills that we're learning. And this exercise is pretty simple. We want to filter what jobs we're going to apply for based on a list of skills. We're going to assume that we have these skills or my skills of Python, SQL, and Excel. And what roles are we going to be filtered from? Well, inside of our repo, we can go into the exercise itself, and I'm providing this list of dictionaries called job roles. I'm going to go ahead and Command C or copy this. And then pasting it into here, we can see that, yes, it is a list of dictionaries for different job roles where we have a key of the job title itself, and then we have a key of the skills and then a list of skills. So in the case of this first one of this data analyst role with the skills requiring of Python, SQL, and Excel, we would want to match on this condition. Now, where it gets tricky is we also need to match where roles may have additional skills. So in this case of this business analyst role, we have those skills of Python, SQL, and also Excel, but they also include Tableau and Power BI. And this is pretty representative of what I would advise to you if you're applying for jobs. If you have the skills, but not necessarily all of them, I would still apply for a role. Anyway, let's actually get into coding this. So for this, the thought process is we're going to loop through this list of job roles, and then secondly, verify this my skills list is in fact inside of this skills key of the dictionary. We'll also need to set a condition for whether a job is qualified or not, but we'll get there in a second. So the first thing I'm going to do is just going to get into cycling in a loop through those job roles and printing out what was displaying, assuming we assigned a variable of job for each job role. We get displayed below all of those different dictionaries inside that list. And so we did that first part, and now we need to get into accessing the skills inside of these dictionaries. And so when we have this job variable, it's basically a dictionary that's getting printed out. So we can use that key of skills, and I can print out that list of skills right here. So you may be thinking we can loop through this job skills and then check if my skills is inside each one of these things, but we run into errors with this. As we wouldn't match on this business intelligence analyst because we'd meet a condition of when we hit this Tableau or Power BI, we wouldn't meet it. Anyway, what we want to do is we want to cycle now through my skills. So we'll define for skill in my skills. And then just checking on this as we go, I'm going to actually print out that skill right above that job skills dictionary. So now we are going to have everything we need. We'll check SQL, Excel, Python, and we'll go through and check each of these lists as we go through it. So we'll now establish a conditional statement to see if it's inside of this list by saying if skill in that job skills. I'm going to indent this over and I'm going to continue to print that skill and job skills for demonstration purposes. We'll delete it a little bit. But we can see it's only printing out Python, SQL, Excel whenever the lists themselves contain those values from the my skill list. But we're checking each item iteratively. So in this case, these top 3 things printed are just for the data analyst itself. So we need to basically establish a Boolean condition in order to keep track of a certain job for when it may not have all the skills necessary. So since this is specific to the job itself, I'm going to define this new variable of qualified up here and set it equal to true. So whenever I get to a new job, that condition will get reset back to true, basically innocent until proven guilty. And then once it's proven guilty or not true, then we'll basically end the loop. So we need something that will change it to where we'll get that qualified equals to false. But if I was to run this as is with also having qualified out, we basically see it saying false even though Python's in there. So we need to do basically an opposite, right? So if skill not in job skills, now running this, we can actually see that skill SQL is not in this list. And continue on, Excel is not in this list. So we've met this condition. And as you can see from this first posting right here, I can tell because the lists are the same with Python, R, machine learning, and deep learning. We don't need to necessarily go through both SQL and then move on to Excel then. We established that we haven't met these conditions, so we need to just break at that point. Running this now, there should be there's no more repetitive lists inside of here. And at this point, we don't need to be printing this anymore, so I can go ahead and remove this. So now we want to see what jobs we're actually qualified for. So I can say if qualified, i.e. we're still true, print out that job. Running Control Enter, we have the data analyst and then also the business intelligence analyst. Now, this job roles was provided to me in a list. The my skills was provided to me in a list. So I want to get this back into a list. Anytime I need to create a list, I'm going to have to define a new empty list. In this case, I'll define qualified roles equal to this blank list where it's just these empty square brackets. And I can prove this list by running the type function on those square brackets. We can see that it is a list, it's just empty. Anyway, you have to initialize the list if we want to actually run methods on it. Specifically, instead of printing out the jobs, we want to take that qualified roles list and we want to append on that job and specifically the role from it. Running Control Enter, and then actually I should have actually printed out this below. So now looking at qualified roles, we get the data analyst and business intelligence analyst. Now, technically, you can write this all more succinctly if instead, this is basically I rewrit this entire thing up here, down below. You could write it more succinctly if you use this all function, which is using a sort of list comprehension inside of it to compare the skills and make sure that the my skills list is inside of the job skills. But we're not going to go into more detail on this all function. Instead, you can do this for homework and evaluate how you could have implemented this all function instead. Which now, looking at this function, if I remove these dang comments out of the way, we can see with how short it is, it's a good candidate for list comprehension. This is what it is in list comprehension form, which is not actually too bad. And you could technically do this, although I find myself, even as an experienced programmer, having issues just writing out list comprehensions quickly and easily. I like to start with functions themselves, and then if I need to condense them down, I can condense them down later. Basically, you're not right or wrong on either one you want to use. If it's easier to go through and writing it out entirely like this, I'm perfectly fine with you doing that. So with that, let's actually jump back into that Python standard library. We only have about 5 more sections that we have to cover for this standard library before we start moving to other libraries like pandas and matplotlib, where we actually are going to be working with the data set. All right, with that, see you in the next one. Now I'm all for automation. Just watch this. Hey Google, turn blue lights on. And I try to automate anything that I can in my life to make it easier. And that's exactly what functions do inside of Python, to basically streamline our lines of code and make it easier for us to execute things with less lines of code. And we've previously seen the use case for functions working through these problems. Let's say, for example, we wanted to see the length of these skills right here. All we have to use is that len function and pass into it skill list. Running Shift Enter, we can see it has 3 items in it. Imagine if every time I wanted to get the length of something like a dictionary or list, I had to call out this formula right here of these 3 lines of code, and then even go as far as to print that count of what's going on there to see that count's 3. And so I love functions, and there's 5 different types that we're going to be covering. One we've already covered, and then some that we're going to be covering up in the next few lessons. So in this section, we're going to dive in deeper to understanding what built-in functions are available to you, and then also how to build your own functions. In the following lessons, we're going to be jumping into Lambda functions or anonymous functions, and then standard library functions. And then finally, my favorite, using third-party libraries like pandas, NumPy, matplotlib. Now, for any hardcore programmers watching this, there are additional functions out there like generator functions, async functions, and recursive functions, but that's just out of the scope of data analytics in general, so we're not going to focus on those. We're going to focus on these. So we've seen a lot of built-in functions already. So we've seen functions like print, that basically print out our things, type, which defines what is the data type of a certain variable, length, and then even the range function where we went and did something from like 0 to 5 and used that. Oh, my favorite one, help. But are we only limited to just these? Like which ones are actually available? Well, if you wanted to, you could just execute this line of code that we're not going to dive deep into it, but it basically goes through, looks into what's available in the current directory in regards to built-in functions, and then returns it in a list using list comprehension. Anyway, we can look inside of here and we can see that it has things that we've already used before, like len and print. But an even better way is probably just go to the Python documentation for built-in functions, and they provide this convenient little chart here on all the different functions, along with all the documentation explaining each of those. Now, we're not going to dive a lot deeper into built-in functions, but I do want to focus on some math-based built-in functions that I use from time to time that you definitely should be aware of. So let's say I had a list of data salaries and I wanted to find different characteristics about this list. If I want to find the minimum, all I'm going to use is the min function and then supply it that data salaries list in order to see it. Here I find that the lowest is 85,000. Conversely, I can also use something like max to find the max value, or even sum to add up all the different values within this list and then display it down below. And my favorite is if I ever need something organized better, I can use the sorted function in order to sort these values into numerical order. So now let's shift focus and actually get into building our own, if you will, user-defined functions in order to do something maybe we need to do. But we're going to start simple first. So if you remember early in our sections, we came up with a formula in order to calculate what the total salary is using the base salary and then the bonus rate. And we figured out it was this formula to get the total salary. Well, imagine if we have a bunch of different base salaries and a bunch of different rates that we need to feed into this. Well, this is a perfect example for a function. So let's start defining this function. Anytime you start a function, you need to start it with the keyword def. And this stands for define. And then from there, we're going to now name the function. And you can create whatever you want. We're going to call this one calculate salary. And then it's very important here, you have to put parentheses and then a colon. Now I want to make sure I executed this right. So similar to our loops and also conditional statements, I can just put in this variable, or I can put in this keyword of pass, and then running it, make sure that it executes properly. So it's working just fine. We need to go further though now and define it. So for right now, just for demonstration purposes, I'm going to paste those variables inside of here just to simplify this. So we have this base salary inside our function, and we have the bonus rate. And we can tell it's inside the function because they're indented in. And then from there, I'm going to calculate that total salary and set it equal to our previous value of the base salary times 1 plus the bonus rate. I'm going to remove this pass because we don't need any more because we have contents in there now. Running this again to make sure that this actually works. We got no errors, good. So now we've defined this function. Let's actually call it and see what we get back from it. So just calling calculate salary and then adding those parentheses, because the parentheses after it is a function call. I'm going to run it, shift enter, and I didn't get anything. Why didn't I get anything? Well, I didn't return anything in the function itself. I returned none, basically. Anyway, I need to specify what I want to return back from this. So I'll specify that here and say for return, I want to provide total salary. Running shift enter here and then shift enter down here. Now, whenever I run this function, we're getting output the total salary because that's what it returned. So now you're probably like, Luke, but this doesn't do me any good. I have to go into this function now to input those variables. Okay, let's make this function actually usable by providing it arguments to then provide us values. So I'm going to remove those variables from inside of here. And now I'm going to define those arguments inside of the parentheses right here. So I'm going to define that we're going to pass it base salary and also bonus rate. So now running this, I can see that the function works fine. Now let's run this calculate salary again and see what we're going to get. We're going to get an error. And it says to us, calculate salary is missing 2 required positional arguments, base salary and bonus rate. So we have to provide that now because the function is built like this, we have to provide that base salary argument and bonus rate. So I'm going to just put in base salary and bonus rate right here. And now running it, it provides it in and then provides us the value. Now, one technical note, these variable names that I'm using right here we're using the same ones, and that's actually not even necessary. Say I want to just actually plug in values, so 150,000 and say a rate of 0.25 as the bonus rate. I can do that, it's still going to run it. Or if I wanted to, I can even change this one to salary 1, and then this one to rate 1, running this up here, and now defining salary 1 inside of here and rate 1 below it, running it, we're going to get that 110,000. I'm going to shift things around a little bit before we continue, just to make sure that we have it all organized. And so now I have the function up above and then the actual function that we're going to execute right below it, and it's executing. I just wanted to make sure you understood that you don't need to have the variables above the function itself. That's not necessary at all. But the function does have to be defined before you actually call it. Now, building on this example further, what happens if we routinely have the same bonus rate and we don't want to necessarily slow down our coding and have to put in that salary rate or that bonus rate every single time? Well, we can add an optional argument. So I want to define that the typical bonus rate is 10%. You may be tempted to want to put something right inside of here to actually specify that we're only going to be using a 0.1 of the bonus rate and then running it. And then if we wanted to remove this from it, well, if we did this, we're going to get a positional error, argument error, because we didn't include that bonus rate. But here's what we do. Instead, we'll define what that bonus rate is right next to the argument itself. We'll set an equal sign and then the value we want to assign to it, should it be optional or not. So in this case, I'm specifying it to be 0.1. I'm going to run this now. Now below this, we're still calling calculate salary and we're only providing one argument of salary 1. Whenever I run this, we get the value. And no matter what I put in there, it's going to work. And in a case where maybe the rate is different, let's say at 0.5%, I want to definitely find that job where it's 0.5%. I could put back in that salary 1 and then that rate 1. And then whenever I run this, we can see 150,000, so 50% of that. It now takes in this rate 1 whenever we provide it overrides that optional argument as point of point one. So that's the basics on built-in functions, which you're obviously familiar with, but also user-defined functions, which we have some practice problems on for you to dive deeper into and test your skills with it. We'll be moving up in the next few sections on that Lambda, standard library functions, and third-party library functions. So I'm looking forward to that. With that, I'll see you in the next one. So Lambda functions, also known as anonymous functions, are very similar in how they operate compared to those user-defined functions, and also built-in functions, and actually calculating or doing some sort of operation. But before diving into this, I'm going to be very clear. So Lambda functions are more of an advanced functionality. If you're not finding yourself using Lambda functions and instead just using regular user-defined functions, there's nothing wrong with that. Lambda functions are just a great way to flex on your coworkers. So here we are on the type of functions cover, which is halfway through with those Lambda functions. I promise you it gets only easier from here after this one. Lambda functions are written by starting with Lambda. Then from there, you provided an argument. In this case, we're just going to name it X for the time being. And it can be any number of arguments. We're just going to do one for right now. Then from there, you do a colon to then go about providing what we want or what formula we want to be conducting on that X argument. In this case, we're just going to keep it simple right now. We'll say X and we want to multiply X times 2. Pressing Shift Enter, we see that it's just a function here, but we actually need to use it and actually see how it works. So I'll call this Lambda function mul2 and set it equal that. Really ingenious right there. Run this again. And now because Python has functions as first class objects, so I can assign this function to a variable name, I can then use it. So I can call mul2 and then in parentheses to call this Lambda function, I can provide it an argument, we'll say 3, running Shift Enter, we get return 6 back. Now this is 2 lines of code right here. Technically, the point of a Lambda function is be able to write something within 1 line. So I could actually take the function, wrap it into parentheses to wrap it up, and then put in parentheses on the outside of it to start the function call of it, and provide the argument of 3, running Shift Enter, we get it. Now, if I wanted to provide multiple arguments to this function, I could separate it with a comma. So in this case, we're going to pass X and Y to it. And then we'll say X times 2 plus Y. And then in the parentheses, we need to specify these 2. So I'll add, let's do 4. Running Shift Enter, we get this, which 3 times 2 is 6 plus 4 is 10. So you're probably like, Luke, how does this actually apply in the real world? Well, let's go back to that previous example that we did in our function section, where we were using this calculate salary function in order to calculate total salary, which is based on base salary times 1 plus the bonus rate. And now let's say with this function, we have a list of salary values we want to pass into it. And in our case, we're going to just assume that all the bonus rates are at, in fact, that 0.1% for all of these to go through it. So how could we, with what we know right now, actually implement it without using lambdas? Well, we can use list comprehension. So I'm going to define this variable of total salary list. I'm going to set it equal to the start of our list comprehension. And we'll define a variable that we're going to be cycling through each of these salaries in the salary list. So I'm going to name it the name salary. And we'll loop through that. So for salary in salary list. Now, you know, I like to iterate through things and make sure my code's working just fine. So I'm just going to print out what I have underneath here. Right now, we're not doing anything, right? We're just reprinting out this list, cycling through it and then reprinting it out. Okay, so all the values that we see above are still in there. Okay, now for list comprehension, right, I can, in that first argument, provide a function to apply to it. So in this case, we can do this calculate salary to this. So I can type in calculate salary, put this into here. Now, whenever I run this, it's going to pass each of those arguments into calculate salary and then feed it out. Bam! And then we have all of those through using list iteration. But right now, we're at just looking at only these lines of code. We're at like 4 lines of code. I'm going to make it even shorter. And technically, running this again to just make sure it works, we can shorten this down, remove that total salary. So the function itself is only about one line of code. And anytime we get into writing a function with one line of code, there's a use case for Lambda functions. So we'll go ahead and comment this out. So we're going to be altering this function right here and basically replacing it with a Lambda function. Remember, anytime we do a Lambda function itself, we need to define it inside of parentheses. And then I'll go Lambda, the variable we're going to pass into it. So in this case, we'll just say X, and then we'll pass back out X. Now for this Lambda function itself, we need to pass in something to it. So we're going to also put a parentheses outside of it for basically calling the arguments, and we'll pass inside of it salary. So let's go ahead and now run this. And having a little typo issue. Lambda was spelled wrong. Need to actually do that right. Anyway, this is providing basically our list back in this case. And so we can do now an expression on it to actually alter it. So I can do times 1.1. And then doing it this way, pressing play, we have those corrected values back. This example was shown in order to display that you can write with Lambda functions one single line of code and write things more succinctly. However, this isn't necessarily completely succinct. Technically, we could just put salary and then times it times 1.1, and we're going to get the same results. And that's what you actually should do in this case. But I wanted to show for demonstration purposes how you could actually use Lambda inside of list comprehension. So let's move on to a slightly more complex example of how we can use Lambda functions in order to clean up or filter our data. So here I have a dictionary of some jobs that are available. In it, I have a job title, the different job skills, and then also this final value here on whether it's remote or not. It's a Boolean value of true or false. If you don't want to type out all those different values I have on the screen right now and you want to follow along, go to your favorite chatbot, type in this prompt of generate a dictionary titled job data. It's a collection of data science job posting. The keys and data types for values for the dictionary are job title string, job skills as a list, and remote Boolean. Okay, and it only provides me one value, so I need to specify, provide, 5 values. From there, you can just copy the code and put it into your notebook. Anyway, we need to make sure that it runs and it's formatted properly so we can continue on. So because we want to filter this data, we're going to use a built-in function for this, and that is the filter function. So let's actually inspect it using my favorite function, help, and doing this for filter. So inside the help on class filter in module built in. For the function itself, it's defined up at the top. Inside of filter itself, you pass a function. So in our case, we're going to be passing our Lambda function to this. And then from there, you pass an iterable, which we have our iterable, our list, our job data to be the iterable. And in it, it returns an iterator yielding those items of iterable for which function items is true. That's just fancy talk for saying it's going to use the function, filter out our values, and provide back the filtered values. So let's show what this does very simply. So I'm going to define that filter function. And then first we're going to put the function that we need to do. And then I'm going to define the Lambda function right here. And we're going to be iterating through the jobs itself. So I'm just going to specify and make up this variable called jobs. And I want to keep this simple right now. I just want to find those where the job of being remote is true. Remember, this function returns an iterator yielding those items of iterable for which the function is true. So I'm just going to put in there job and specify also remote because we want to look at the job remote column. From there, the next argument of this is the iterable, which in this case is jobs data. Running shift enter, we get a syntax error. And I think it's because we need to actually wrap this all within a parentheses to basically make it a function in itself. And I'm going to run it again. All right, oh my goodness. This is why, this is a silly error. I just realized what I did. I misspelled Lambda. I should have just looked at the highlighting right there. And I don't need the parentheses around it. Actually running this, we get a filter object returned. And so we need to convert this to something we can actually see. So I'm going to convert this back into a list and we'll print that out, running that shift enter. We can see we get back only the jobs where remote is true. And it looks like 3 of them are true. That's true. But remember, we want to find not only where the remote jobs are true, but also where the job skills contains Python. So I need to modify what we're doing, the operation that we're doing in here. So we can use that AND operator to make sure that both of these conditions are going to be true in order to satisfy this filter function. And we want to verify that Python, oops, we need to type it like it is in the list. Python is in the job skills column. Okay, so now we have it in the job skills column. Now let's run this. Bam! Okay, so now we have the two in here and we can see the job skill is Python in both of these and it's remote in both. So that's really the two major ways that I've seen Lambda functions used, whether it's inside of something like list comprehension or built-in functions like